See, now we are discussing about P block elements. In that P block elements, some important compounds we are going to discuss. In 15th group, first compound, you take nitrogen. So nitrogen compound, in this, every compound, preparations, chemical properties, that are two only important. So preparations. So preparation of nitrogen. We want to prepare nitrogen means, so what are the nitrogen compounds? All you write down at one place. So here NH4 NO2. So ammonium nitrate. Next ammonium dichromate. Next you take ammonia hydrogen N2H4. Next you are going to organic chemistry means RNH2 amine. So amine is similar to, so urea you take C double bond O NH2 NH2. Next any other compound means that azide. So barium azide. So these all are what? Nitrogen contained compounds. From these you can prepare nitrogen. See, you take NH4NO2. NH4NO2, ammonium nitrate. Just you heat. Hydrogen and oxygen are eliminated. You are getting nitrogen plus 2 moles of H2O. You are getting nitrogen. Next, ammonium dichromate. NH4 taken twice, Cr2O7. Just you heat. So you are getting Cr2O3. So famous compound. Next, 4H2O. So 3 plus 4, 7 oxygens are gone. So you are getting the nitrogen gas. Next, NH3. See, ammonia. So in ammonia, you remove the hydrogen, you will get nitrogen. So how you can remove this one? You treat with oxygen. So oxygen related compounds. So that is what? You are getting 3H2O plus nitrogen gas. So you take a 3 by 2 O2. See, otherwise, oxygen supplied compound also you can take. See, NH3 CuO. So CuO, copper is a large size, oxygen is a small size, so unstable. So it is supplies oxygen easily. So then what happens? So here H2O, 2 moles. So 3H2O. So you take 3 moles of CuO. So you are getting 3 oxygens are over, 3H2 is over. Next nitrogen gas is coming, 3 moles of copper. Okay, next, so you take NH3 oxidizing agent. See, not only copper oxide, mercuric oxide also you can take. Same procedure you will get. Otherwise, NH3 you treated with chlorine also. So you are getting nitrogen plus HCl, hydrogen and chlorine. See, suppose you take 2 NH3. So nitrogen gas is coming 3 hydrogens. 3 to the 6. 6 means here you take 6 HCl. So ammonia is base, HCl is acid. So again the product is again reacted. So you are getting 6 NH3 plus 6 HCl. You are getting base plus acid, you are getting salt, 6 NH4Cl. So here 6 HCl, 6 HCl is cancelled. So 8 NH3 plus 3Cl2 gives rise N2 plus 6 NH4Cl. So that means chlorine is reactive with excess ammonia. Your answer is N2. Next. So similarly, N2H4 also. Suppose you take N2H4. This is hydrogen similar to ammonia only. So you treat it with suppose platinum chloride PtCl4. Actually platinum is what? Noble metal. So that compounds are unstable. So it supplies chlorine, it supplies hydrogen. So then what happens? Nitrogen gas is coming, platinum is separated, plus 4HCl is coming outside. Suppose gold also you can take N2H4, gold chloride, AuCl3, you are heated. So HCl is coming outside. Gold is separated, nitrogen gas is coming outside. Suppose you want to balance 4 chlorines, 12. So here 3, 12 HCl, 3 nitrogen, 4 gold. So logically you can think and complete that preparations also. Next, amines, your organic chemistry, RNH2. See, you take N double bond OH. So that means what? HNO2, nitrous acid. Amines are treated with nitrous acid. So that means what? Water is separated, N2 separated. Your answer is what? Alcohol plus nitrogen plus water. So amine. So urea you take. Urea also 2 moles. C double bond O, NH2, NH2. So you take here HNO2, here HNO2. So here H2O, N2. Here H2O, N2. Eliminated. So you are getting 2 moles of N2, 2 moles of water, plus CO is connected with 2 OHs. So H2CO3. Nothing but you can write H2O plus CO2. So these two are organic chemistry. Next, barium azide. So barium azide, directly you heat. So barium is separated. So 3 moles of nitrogen gas. So this is a solid, this is gas. So you are getting pure nitrogen is available in the heating of barium azide. Next, so nitrogen, chemical properties. So chemical properties means we take nitrogen and prepare other compounds. So nitrogen. So nitrogen is heated with hydrogen, heated with oxygen. These are common things. Next, nitrogen highest electronegative. So that's why you can treat with highest electropositive metals also. Next, another important, treated with calcium carbide. Next, carbon plus Al2O3. This is Serpex process. So one by one we can discuss. See, nitrogen react with hydrogen. So 3 moles. So you are getting 2 moles of ammonia. So it is a reversible reaction. So this is what Haber's process. So ammonia prepared in Haber's process. So who is the catalyst? Iron is the catalyst. Next, molybdenum is the promoter. So Haber's process. Next, nitrogen treated with oxygen. N2 plus O2 gives rise to NO. Otherwise, N2 plus O2, so 2NO2. So 2 moles. 1:1 ratio, 1:2 ratio at different temperatures. So you can get that one. Next, this is what? Nitric oxide, nitrogen dioxide. Next, metals. So nitrogen react with lithium. So you are getting Li3N. See, nitrogen react with magnesium, Mg3N2. Nitrogen react with aluminium, Aln. So aluminium nitride you are getting. Next, calcium carbide. These two are important. So nitrogen react with calcium carbide. Nitrogen react with CaC2. So you are getting CaCN2 plus one carbon is coming outside. So this is calcium cyanamide. Calcium cyanamide. So not cyanide. Cyanide is different. Calcium cyanide means this is Cn taken twice. That is cyanide. This is cyanamide. So this combination you called as nitrolim. So what is the importance means this calcium cyanide treated with water, you are getting ammonia. So that is one important preparation of ammonia. So that is called as a cyanamide process also. Next, here another important Serpex process. Al2O3 is nothing but bauxite. So purification of bauxite, one of the thing is Serpex process. In this, nitrogen react with Al2O3 in the presence of carbon. So then what happens? Carbon is taken oxygen. So carbon monoxide is going outside, aluminium combining with nitrogen. So you are getting Aln. So carbon monoxide is going outside, you are getting pure Aln, solid. So now it is treated with water. So you are getting AlOH taken thrice plus N-3H plus. So you are getting ammonia gas. So byproduct is ammonia coming outside. Next, AlOH taken thrice, you are heating means you are getting Al2O3. So pure Al2O3 in metallurgy. So that alumina, this is Al2O3 you called as bauxite. One of the purification of bauxite is Serpex process. Next, second compound we are going to discuss about ammonia. So ammonia preparations. So preparation of ammonia. So again here also you are taken nitrogen compounds. So all nitrogen compounds you can take. Say nitrogen compound means, so what we can take aluminium nitride, magnesium nitride. So nitrogen related compounds. Next, ammonium chloride, nitrogen is there. Next, sodium nitrite, sodium nitrate, so nitrogen is there. Next, urea is there, C double bond O, NH2, NH2, urea. Next, previous only we discussed calcium cyanamide, so CaCN2, so here also. Next, salt NH4Cl, so ammonium sulfate. So nitrogen compounds you can take one by one, you can identify. See, Aln, Aluminium is plus 3, nitrogen is minus 3. Directly you add water. So H plus OH minus. So directly you are getting NH3 plus AlOH taken thrice. Same Mg3N2 plus water. So you are getting 2 NH3. So 6 plus 3 MgOH taken twice. Next NH4Cl. So NH4Cl is a combination of what? NH3 plus HCl. So you remove the HCl from this, you will get NH3. So you treat it with NaOH. So you are getting NaCl plus H2O plus ammonia. You are getting outside. Next NaNO2. So NaNO2, you add water. Hydrogens, water eliminated, hydrogens, ammonia eliminated. So hydrogens you are treated. Then what happens? See, suppose zinc plus NaOH, we are taken. So they supplies water, hydrogens. So what happens? N is there, NH3 is coming outside. O is there, hydrogens you are supplying. So you are getting H2O. Sodium is there, oxygen is there, hydrogens are there. So you are getting so NaOH. So combination. So you are getting. So mainly hydrogen releasing substances. That is. Next, urea is there. So urea, NH2, CO, NH2. See, here you take NaOH. NaOH. So bond is breakages. Here also NaOH. So what happens? 2 moles of ammonia plus Na2CO3. Otherwise, you can add water. Next, water after. So that NaOH. Otherwise, you can get directly. That. So mainly, ammonia is prepared in what way? So ammonia, Haber process, cyanamide process. So Haber, already we seen. So Haber's process means N2 plus 3H2 equilibrium. Iron is the catalyst, molybdenum is the promoter. You are getting 2 moles of ammonia. Next, cyanamide process. So cyanamide process, already we are completed N2 plus CaC2. You are getting CaCN2. Carbon is eliminated. So now it is treated with water. You are getting ammonia. So one is a cyanamide process, another one is a Haber's process. Next, you take chemical properties. So ammonia chemical properties. So you take ammonia. So generally, so we can heat it. So directly you can heat, otherwise oxygen, hydrogen. Already hydrogen is there. So no need to think about hydrogen. Just you take oxygen. So ammonia is base. So ammonia base means readily react with acids. That. Next, you can treat with excess chlorine. So chlorine, this is the excess. Otherwise ammonia is excess. So two important reactions are there with the ammonia. Next, here already hydrogen compound is there. It supplies hydrogen. So oxygen compounds you can add. So CuO, NaOCl. So bleaching powder, CaOCl2. So anything oxygen easily supplying. So all are react with this one. That is. Next, so famous first A group elements, sodium. So sodium plus liquid ammonia, it will give trans product in your organic chemistry. So that is called as Birch reagent. Next, ammonia treated with CO2, what happens? Next, how to detect ammonia? That is Nessler's reagent. What is that? K2HgI4. So all we will discuss one by one. NH3 react with oxygen. So then what happens? You are getting it. So nitrogen also react with oxygen. You are getting NO. This is also reacted. You are getting H2O. So you can balance that one. Next, ammonia react with acid. So ammonia react with HCl, ammonium chloride. Next, ammonia react with HNO3. So ammonium nitrate. Ammonia plus H2SO4. Ammonium sulfate. See, ammonium chloride, ammonium nitrate, ammonium sulfate, these all are what? Fertilizers. So nitrogen supplying fertilizers. Next. So ammonia react with chlorine. So NH3 plus Cl2. So already we discussed now only. So you can take 2 moles. So N2 is coming plus 6H6HCl. See, ammonia is base, that is acid. So that's why 6HCl react with 6 ammonia. So you are getting 6 NH4Cl. So 6HCl, 6HCl is cancelled. So you are getting 8 ammonia plus 3Cl2 gives rise N2 plus 6 NH4Cl. You are getting. So ammonia is excess. Your answer is N2 is getting. Now chlorine you take excess. So NH3 plus Cl2. See here. So 1:3. This is excess. So nitrogen also react with chlorine. So you are getting NCl3. Plus 3 hydrogens react with this 3HCl. So NCl3 and HCl. If chlorine you are taken excess amount. So two important concepts. Next. See NH3. NH3 is what? Reducing agent. So because of it supplies hydrogen. So you take oxidizing agents. So what are oxidizing agent? So copper oxide. So unstable. Large size, small size. Mercury oxide. Large size, small size of oxygen. Next, sodium hypochlorite. Nascent oxygen. So bleaching powder, CaOCl2 supplies oxygen. So all are what? Oxidizing agents. So then, so what happens here? Hydrogen eliminated, here oxygen is eliminated. You are getting what? Nitrogen gas. That is plus H2O. Next, sodium plus liquid ammonia. So in the organic chemistry, famous, as well as first group elements also it is coming. See, sodium loses one electron. It becomes as Na plus and electron. Na plus is surrounded with ammonia. Next, free electron also surrounded with ammonia. So because of ammoniated free electron, it is showing paramagnetism, and this total solution is observed in blue color. So after some time you see, so sodium is reactive with ammonia, you are getting NaNH2 plus hydrogen gas is coming outside and it become as a red color. So hydrogen is coming outside, so that's why sodium plus liquid ammonia is acting as a reducing agent. So here the alkynes are converted into alkene. CH triple bond CH is converted into alkene. So Solietra famous in the organic chemistry. Next, ammonia react with carbon dioxide. So 2 moles of ammonia react with carbon dioxide. First you are getting NH2CO NH4 plus. So that salt you are getting, now further heating you are getting urea. Plus water is eliminated. So when ammonia treated with carbon dioxide, at last you are getting urea. Next K2HgI4, that is famous. That is what ammonia detection purpose. So with Nessler's reagent. So Nessler's reagent is what? K2HgI4. Suppose ammonia react with K2HgI4. So then you will get a brown precipitate actually. NH2HgO HgI. So brown precipitate. So based on this, this is the identification test for ammonia. Next. See, suppose ammonia is treated with NaOCl. So you are getting A compound. That is treated with ammonia. Ammonia, you are getting a B compound. Otherwise, N2H4. So hydrogen. So what you will get? See here. So NaOCl, what happens? NaOH is separated. You are getting chloramine. So NaO1H is eliminated. So you are getting a chloramine. Chloramine treated with ammonia. So HCl is eliminated. Your answer is N2H4 hydrogen. Suppose here you take 2 moles. 2 moles of chloramine. Treated with hydrogen N2H4. So you are getting ammonium chloride. 2 moles of NH4Cl. Next, what is remaining? Nitrogen gas is coming outside. Suppose they are provided here B plus and C plus D. So like that. Next, one important identification of ammonia. See, identification of ammonia is the important. So ammonia, that is fumes. So odor. So ammonia smell. By seeing smell also you can identify. Next, litmus. See, this is what base. So base means what it will do. Litmus paper that become as red color to blue color. Red litmus is converted into blue litmus. That also you can identify. Next, you send HCl. If you are sending HCl means you are getting NH4Cl, dense fumes. So by seeing dense fumes, so you can identify ammonia is coming there. Next, already we see Nessler's reagent K2HgI4. Nessler's reagent, what you are getting? NH2 HgO HgI. So this is what? Brown color. So brown color also you can identify. Next, chloroplatinic acid. So that is H2PtCl6. It is treated, you are getting ammonium chloroplatinate. So this is showing yellow color. So these are the identification test for ammonia. Next, some important ammotalu, ammonal. Two important compounds. Ammotal. See, ammo means ammonium nitrate. Ammonium nitrate plus tall, that is what? TNT, trinitrotoluene. So that combination also, ammonium nitrate is 80%, trinitrotoluene, that is 20%. So these are what? Explosives actually. Next, ammonal. So ammo means ammonium nitrate plus aluminium. So aluminium is a small amount. So these two are used as explosives. So ammotalu, ammonal. So two important. Next, nitrogen oxides. See, already we discussed once again. You take nitrous oxide, nitric oxide. So dinitrogen trioxide. So nitrogen sesquioxide. So dinitrogen tetroxide. You are also nitrogen dioxide, N2O5. Nitrogen, dinitrogen pentoxide. See, these two are neutral. So these are acidic. This famous name is laughing gas. Next, NO contains unpaired single electron. NO2 contains unpaired single electron. So that's why this is showing paramagnetic, colorless. This is paramagnetic but brown color. Next, N2O3 diamagnetic but blue color. So already we seen these things. Next, one preparation only famous is there. So logically, so copper plus HNO3. See, here 1:4 ratio. Copper is 1, HNO3 4 ratio. So your product is N2O4. N2O4, otherwise 2 moles of NO2. Next, 2:6. You increase one number, you are increasing two numbers. So 2:6, N2O3. N2O3 is a combination of NO plus NO2. That. Next, 3 is to 8. So next, 4 after 3, 3 after 2, N2O2. Otherwise, 2 moles of NO is available. Next, 4 is to 10. So next one, N2O. You are getting. Next, 5 is to 12. You are getting nitrogen gas. So this ratios the compound they will ask. Very, very important. So that one. Next, other than this, some special we can see. So some speciality of different compounds. See, ammonium nitrate. See, ammonium nitrite you take. NH4NO2 you heat. NH4NO3 you heat. Ammonium nitrate. Next, lead nitrate. So wherever the disturbance is there, wherever the confusion is there, that is only our entrance. Here, 4 hydrogens, 2 oxygens. So water is eliminated. Your answer is N2. Here, 4 hydrogens, 2 oxygen is eliminated. Your answer is N2O. So ammonium nitrate gives N2. Ammonium nitrate gives N2O. Lead nitrate gives NO2. So very, very important. More confusion. So compulsory question. So that is one. Next. So NO and NO2 both are famous. So NO contains a single electron. NO2 contains a single electron. So both are combining. You are getting N2O3. Next, NO contains a single electron. You are treated with chlorine. Your answer is NOCl is possible. NO2 also single electron. You treated with chlorine. So you are getting NO2Cl. Nitrosyl chloride, nitronium chloride. So this is single electrons. So that is important one. Next, NO is a famous brown ring test. So the same NO is useful in brown ring test. So in brown ring test also, FeSO4, freshly prepared ferrous sulfate is treated with NO. So you are getting FeSO4NO, brown rum. So otherwise, Fe, complex nature also you can take. H2O taken 6 sulfate. You treated with NO. So you are getting Fe, H2O taken 5, NO, SO4. So nitrosoferrous sulfate you called as a brown ring. So here this ligand has a positive charge. So iron oxidation state is a +1 in the brown ring. So this is important. Next. So non-metal oxides. Already many times we discussed non-metal oxide reactive with water. So you are getting oxo acids. So N2O and NO, these are neutral. So they are not reactive with water. So you take N2O3 plus water. So you are getting 2 moles of HNO2. Next, N2O4 reactive with water. So you are getting HNO2 plus HNO3. So this N2O4 you called as a mixed anhydride. Mixed anhydride of nitrous and nitric oxide. N2O5 treated with water. You are getting 2 moles of HNO3. So here. So in this compounds N2O5 is somewhat speciality is there in N2O5. So here, what is this? It is available in solid form. Actually, N2O5 is what? Non-metal. Non-metals means they are available in liquid or gas only. But N2O5 is available solid. In what way it is a solid means? Here, it contains NO2 plus ion is attracted with NO3 minus ion. So because of strong electrostatic attractions between plus and minus, it is available as a crystal or solid. So because of this combination, suppose N2O5 react with NaCl, what is answer? NO2 plus react with Cl minus, your answer is NO2Cl. So Na plus react with NO3 minus, NaNO3. Suppose N2O5 react with sodium metal. So sodium, what happens? It becomes as Na plus electron. So Na plus react with N2O5. So that means what? NaNO3 plus NO2 plus combining with electron. You are getting NO2 gas. So these are some important about N2O5.